Yeah, thank you, Megan. Appreciate the invitation to present today. I think hopefully we will have a lot of time for questions. I know that that will be important as well. So, just a little background on the presentation first. We've got folks here from RCMAP, myself, from RAP, Sarah, and from LANDFIRE, Josh and John, and I think there's several others as well. And I know a lot of you all might use one or more of those data types, and there often is questions that arise from just thinking about how these data work together. How can we leverage multiple sources of information to better answer a question? How do we handle contradictions? What sort of products might be better for certain applications than others? Those are the sort of questions we're going to try to at least address in part today. I'm not sure if we're going to get final answers on all of those. Let's see if my slides can advance. Okay. All right. So just a brief overview of the three products we're talking about today. LANDFIRE. There's a number of data sets that LANDFIRE produces. Okay. Yeah. No worries. Yeah, so LANDFIRE produces a number of data sets like existing vegetation cover, type, fire regime, biophysical settings, etc. A lot of these data sets have a more fire-centric application in mind, although a lot of overlap exists in these data sets between what RCMAP and RAP produce. So moving to the fractional veg component side, RCMAP and RAP, I would say the flagship product on both of those projects is going to be the annual time series of fractional vegetation cover. So shrub cover, bare ground, tree cover, these sort of things, annual scale products at 30-meter resolution over the Landsat archive. So RCMAP also produces a series of weekly temporal resolution, exotic annual grass data, some work on future projections of fractional cover based on some climate scenarios and ecological potential, which is just the potential cover given a lack of disturbance and a lack of invasion from invasive grasses. So RAP has the same sort of annual time series with many of the same components that RCMAP does. There's a little difference there in what components are mapped. RAP has now also released a second set of 10-meter scale data using Sentinel data from 2018 onwards, and I think there is some additional floristic detail in those maps relative to the 30-meter maps. RAP also does produce herbaceous and shrub biomass production estimates. I think those are done on a weekly time scale during the course of the year. So no surprise that there's questions on this. A lot of these products are sort of addressing some of the same issues that we're trying to address. Fire, a big one. Grazing, another big one. Wildlife habitat assessments, these sort of things. I mean, it's in the same ecosystem. So looking at some boilerplate statistics here, it's always kind of important to familiarize ourselves with the specifications of the product. So all the products we're talking about here today have 30-meter resolution data. RAP, as I mentioned, now has 10-meter resolution cover products as well. So we're operating in the same resolution, which is good. Frequency, that's a little bit different among the products. LANDFIRE varies on their update schedule. RAP has annual cover products, same as RCMAP, and I misspoke before, 16-day biomass production estimates, and RCMAP does weekly EAG and soon total herbaceous cover estimates as well. The time periods, there is overlap from 99 to present. RAP goes back to 84, RCMAP goes back to 85, back to 2018 on those 10-meter products in RAP. So some significant temporal overlap. Most of these products are talking about percent cover. So LANDFIRE has a set of 3 fractional veg components that are probably the most similar to RAP and RCMAP, the fractional component or cover of herbaceous shrub and tree. Many of the other Landfire products are going to be thematic data, so not fractional at all. Latency is also important to think about. I think Landfire is normally sort of a yearly cadence on their releases. A 1 month lag in RAP in terms of, like, for example, getting 2025 products out would be done the first month into 2026. For RCMAP, we are typically about 3 months behind that sort of calendar year break. Okay, so moving on from those boilerplate statistics, thinking about the differences in training data between these projects is really important. Differences in training data distribution in space and time will drive differences in predictions. The project focus varies also, change detection varies. We'll get into that a little bit more. I'm also going to talk about accuracy considerations for really all remote sensing products, including all three of the ones we're talking about today. We're going to go through an example of a workflow supplied by Matt Reeves in the Forest Service on using all of these data sets together in a fuels mapping application. And finally, we'll talk about some general considerations for users in applying data sets like these in their analysis and decision making. And I've got an example here, a graphic. This is in Colorado, a Landsat image versus a Landfire product versus a fractional veg product, in this case from RCMAP. It's just a different way of seeing the world. I think there's a lot of alignment in these sort of spatial and temporal patterns, but it's just a different kind of measuring stick in many cases. All right, so digging into the project focus a bit here. Landfire's bread and butter is really fire and all things fire related. So the focus is classification of contemporary conditions with attention to the influence of fire and disturbance. So the product is really a snapshot of current conditions and not designed for backwards compatibility. That's an important point to discuss here. From my understanding of Landfire, Josh or John, correct me if I'm wrong, but you shouldn't really use Landfire for time series applications. It really should be like a single point in time application, and the most contemporary product would be the one you would want to use for fuels work moving forward. RCMAP and RAP are, on the other hand, explicitly time series focused products. We have less of a focus on fire applications. Definitely that's a critical use of the data, but we, I think, have a more generic focus for the products. They could be applicable, of course, to fire management, to grazing decision making, permitting, evaluating the impacts of vegetation treatments, all sorts of different wildlife applications as well. So to summarize, the fractional veg components, RCMAP and RAP, are really designed for more generic applications versus more of a fire-focused application in mind for Landfire. So I show an example here on the bottom of what you can see with fractional veg data. I mean, I think a lot of us have played around with this as well. In this case, showing the value of looking at that long time series record here in southern Nebraska, showing the widespread pattern of increasing tree cover through time, resulting in a reduction in herbaceous cover except in burned areas. And we can dig into what's going on at each one of these pixels, and there's really a story to be told in many cases looking at time. Again, I think time is probably the most valuable part of these fractional veg components.
Hey, Matt, you accidentally muted yourself.
Muted myself. I don't know how I managed to do that.
I
I didn't
didn't. I
click the mute
promise I
button.
didn't do it.
Okay. Well, my bad. Hopefully you didn't miss too much. But I was going to say, there's been some recent work comparing Landfire to fractional veg cover data. For example, the Price et al. The example I'm showing here looked in Idaho at City of Rocks and Craters of the Moon, comparing how a fuel model or fuel bed maps derived from Landfire compared to those derived from, in this case, RAP, I believe. And they also made a custom local model trained from their own field observations for this region and compared that against the results of Landfire. And their overall results were, not surprisingly, that fractional veg products tend to overestimate low cover and underestimate high cover. That's a pattern we see over and over again, and I'll get into that a bit more later. They also noted some disagreements in these fuel bed maps and some differences in the spatial patterning of wildfire as a result of these differences in vegetation products. So, just to highlight, these products are different. There are analyses highlighting these sort of differences. This is just one example. There are several others out there. One key difference between Landfire and the fractional veg cover products is the training data, specifically the perspective in which the training data was observed. So there are two major ways of thinking about observing a vegetation cover plot. So there's first hit and any hit. The first hit is thinking about, from a vertical perspective, what would be the first item of plant material you would intercept. And you would only record that as your observation. You would not consider anything in overlapping canopy below that. In any hit data, you could have multiple hits from a vertical perspective. So you could hit a shrub canopy and an herbaceous canopy below that, and that would count in multiple cases. This creates confusion because Landfire is trained on any hit data, and the fractional veg cover products are going to be trained on first hit data. So for forestry fire applications like Landfire focuses on, the any hit data does make a lot of sense because you need to think about ladder fuels and how that all operates. Looking at the AIM database, this is the BLM's flagship monitoring database, we can look at these differences between first hit and any hit observations. So, because both of those sets of data are available in the AIM database. And the interesting thing here, if you plot the any hit data on the x-axis versus the first hit on the y-axis, the correlations aren't terrible. There is a lot of scatter in the herbaceous component. The further up the canopy you move, the more and more agreement there is, which would make sense. There's not going to be a lot of things overlapping a tree. So the first hit and any hit data are more synonymous with tree cover, less synonymous with shrub cover, and even more disagreement with herbaceous cover. Okay, so thinking about the different sources of data now, moving beyond the first versus any hit distinction. All three of these products are pulling in AIM data. Fantastic. Publicly available. Great. Love AIM data. The NRI project or program data is used by Landfire and RAP, not yet by RCMAP. That's held a bit more tightly by USDA. Same with FIA, is used only by Landfire at this point, not by the fractional veg cover products. Both Landfire and RAP use this Landfire reference database, at least the publicly facing version of that in RCMAP. And one of the unique things about RCMAP versus RAP is RCMAP has a whole series of high resolution derived training sites where we sent people out to the ground, collected field observations on high resolution images, and extrapolated those out across these footprints, later turning that into 30-meter scale training data for our models. We obviously use that in RCMAP. LANDFIRE has been integrating at least some of that data to train their models as well. The bottom line here is that the training data distribution in both space and time will drive the cover predictions, the ultimate maps you all see. So, for example, if the training data was only coming from BLM sites, that would possibly result in bias in the application of the model outside of that. So that's an important thing to think through. What models are using which data sets? So here's a map of what that looks like. On the left, we've got all the BLM points in dark brown, all the AIM points, I should say, in dark brown. The NRI points are focused on private lands in the Great Plains in particular. And then the FIA data has data in pretty much every forested landscape across CONUS. So thinking about which one of those goes into each of these data sets is definitely important. I mentioned the RCMAP high resolution training sites. Those are all these red squares here, which actually are 15 by 15 kilometer footprints of high resolution imagery. So that is unique in its high N, because these are derived from high resolution sites. We can get a really high training N, in this case nearly 70 million potential 30-meter scale pixels to train on. The next element I'm going to focus on is change detection. So in LANDFIRE products, there is a change detection method that's basically collecting different sources of disturbance across the landscape. So in this example, I'm looking at 2024 areas that have been burned, developed, clear cut, etc. All noted. LANDFIRE puts together a database and I think releases this annual disturbance product as well. So the 2024 products from LANDFIRE will only be different from the 2023 products in the footprint of these annual disturbance events. In the fractional veg cover products, we don't have that kind of limitation. The differences from year to year are going to be based on spectral differences in Landsat, or in this case for RAP now with 10-meter products and Sentinel imagery. And wherever there's a spectral change that the model doesn't think, whatever the model is associating with a change in cover value, it is mapped as such. So the point here is that the footprint of change from a year-to-year basis will be far greater in the fractional veg cover products than in the LANDFIRE products. Part of that also has to do with a different measuring stick. So within a LANDFIRE, many of those products are going to be thematic. So there's a certain class assigned to the pixel, and there could be variability within that class that is not large enough to change the class. And that sort of within class change is mostly what's representing this within or year-to-year variation in the fractional veg cover products. Moving on to how would you think through applying one of these three products in your local analysis, or potentially more than one? I'm going to walk through some considerations for local accuracy assessments. Basically, how accurate are these products in my study area? So these products, especially the fractional veg cover products, produce these boilerplate statistics on independent accuracy across the entire study area. So that's a generic number that's pulling in data from all sorts of different locations, from Colorado and Kansas and Montana and all all the study area, pulling all those numbers together. So those numbers should not be interpreted as the accuracy in your particular area of interest. They could be related to it, but they're not synonymous. That's one thing to be aware of. Also, another thing to be aware of is that these accuracy assessments are relative to field data, which themselves contain error. So these accuracy assessments add the error from both the remote sensing classification and the field data. We do have enough information now to start get at like the accuracy of these products by ecoregion, which is sort of informative. The bottom line there is that the more of this component you have within a region, the more accurate it's going to be. So, for example, there's lots of shrubs in the Great Basin. Those shrub classifications would be more accurate than a shrub classification in the Great Plains, for instance, where shrub cover is lower on average, at least. So, going into a little bit more detail here, you've got a certain question you're trying to answer. You're considering LANDFIRE, RAP, RCMAP data to answer this question, whatever the question is. The first thing I would recommend you do is look at the criteria you're trying to measure. Is it going to be like where the absolute amount matters? Is shrub cover increasing? Do we need to know how much it's increasing? Do we just need to know, is it increasing or not increasing? These sort of questions. Basically, what I'm saying is, can thematic data be used, or do you need more nuanced information from like fractional veg cover products? Or is it a question of just presence, absence of invasives, for example? I think framing the question from a user perspective is definitely an important thing to think through. Do you have enough data to adequately capture the range of variability in the area you're trying to work on? One important caveat there is, if you're using local AIM data to evaluate the products, most of those points have been used to train these products, so they shouldn't be considered independent. You would need to pull in additional data collected by yourself or other lines of evidence from soils maps, from climate data, etc., to serve as a proxy sort of validation. Another important thing to think through is the scale of the remote sensing products versus the scale of the question you're trying to address. So if you're looking at like how much tree cover varies throughout the course of the year, but you're looking at an annual temporal resolution product, that's not going to be a good fit. I already mentioned this, the lack of independence for many of the AIM sites. Only 10% of the AIM sites are independent to all three of these products. And again, recognizing that field data itself does contain error is an important thing. So these products also vary in definition. What is included in each component? What, for example, where do cacti go? I can say in RCMAP they go in the shrub component, which is not ideal. It might be handled differently in RAP. It might be different in LANDFIRE as well. Basically, what is included in each component is going to be an important consideration, and all of that should be provided in the remotely sensed product observation. Talked through that a little bit, the first hit versus any hit data. A couple other accuracy considerations to think through. More common values are predicted more accurately. I think that goes for all three of these products. So this analysis is looking at the entire AIM database. We're up to like 70,000 points at this point. So just thinking about how frequent that observation is in the database relative to the error in our predictions for that cover bin, there's a really strong correlation there. So the more common that observation is in the training database, the less error you're going to have on average in that prediction. So something really common like a 10% shrub cover prediction or training is going to be predicted with lower error on average than something like a 99% shrub cover uh, field observation, which is definitely less common in the AIM database. Another thing to think through is spatial scale. We've done some analysis on this, a paper published last year, thinking about how error relates to the spatial scale in which you're applying the data. I think a lot of people want to apply data at a single pixel resolution, though I know in the LANDFIRE metadata it talks about the products really being designed for a landscape scale application. So we did some analysis on this, and it turns out that the coarser the scale you look, in this case we're looking at RCMAP data. I think the same pattern would hold for RAP data as well, and really for LANDFIRE data also. The more you spatially aggregate the data, the more coarse a grain you look at the data, the lower the error in the products is. I mentioned this already. This is a common theme we see in all remote sensing classifications. We have underprediction of the low values, or actually other way around, underprediction of high values and overprediction of low values. So in other words, regression to the mean. This is a model effect of dampening the high end and low end. So LANDFIRE and RCMAP have been working to collaborate more over the years in terms of sharing training data. Mentioned that RCMAP is pulling in data from the LANDFIRE reference database. We're currently investigating potentially supplementing the ModFizz seasonal fuel maps produced by LANDFIRE with these new updated RCMAP EAG weekly cover predictions. This is especially important in places that are dominated by invasive grasses like cheatgrass and buffalo grass, where year-to-year variation can be really large and have big difference or large impacts on fire behavior. I think I'm going to hand it over to Josh now. He's going to provide a case study from Matt Reeves in the Forest Service.
Yeah, thank you, Matthew. Take it over again. Thank you to Matthew Reeves for putting the slides together. You can go to the next slide, please. Okay, so non-forest fuel mapping, what fuel is there? So for example, in this top image, you can see that there's a ton of annual grasses surrounded by shrubs, whereas the bottom image you see mostly shrubs. And this strongly affects, again, surface fuel fire behavior models, the Scott and Bergen models, for example, and also just the simulations, NiftyDis, FSIM, FarSight, FlameMap, et cetera, 3D models, QuickFire. So all these play a role, and the fuels, especially fine fuels, strongly influence these models. Go to the next slide. In this example, we're looking at two different time periods of non-forest fuel non-forested fuel mapping. You can see in the bottom image of the 2021 site, your fuel loading is much lower than the 2022. You have 60 pounds per acre versus 2,600 pounds per acre. And if you look towards the graph on the right, this really affects, in this case, flame length. And so you can see that there's a big difference between someone with nearly 50 times, not quite, but 40 times the amount of fuel. And this really affects fire behavior. So things can change very rapidly. This goes into some of the stuff that Matthew's been talking about well, for example, from a LANDFIRE perspective, that was originally our ModFizz, and from RCMAP, this is the EAG. And as Matthew mentioned, these are kind of hopefully we're going to do some more work together. to try to address this problem, when you've got these year-over-year changes that are dramatic, you don't generally get year-over-year changes in forest ecosystems that are just dramatic unless you have a forest fire that comes through and wipes out all the trees. So these are very quick changes that really affect fire behavior. You can go to the next slide. So how do we kind of look at this? If we're looking at the past versus the present. So we can look at the surface fire fuel behavior and kind of create an ingredient list of ways to modify this, to modify the fuels. For example, you can look at vegetation cover. You can change this with RCMAP data. Vegetation height data we could get from LANDFIRE, especially from products where there's not a yearly product. And height, and this would be shrub, is not going to change necessarily quite as much as cover. It depends. Herbaceous height changes quite a bit. Annual grass cover. So you get this from USGS EAG or the Rangeland Analysis Program, or total production by life form, which is a rangeland production monitoring service product. So the idea is we can alter fuels based on these different products, based upon what we're actually seeing, in this case in the past, but when we're seeing when we want to model during a certain time period. Next slide, please. So in this example, you can see on the image on the right, there's a lot of grass here. So this is, again, if we're looking at a past site, there's a lot of grass that's going to carry the fire. In this example, this is a dry climate. I mean, there's yearly variation in moisture. Again, that could be another data set that helps inform your kind of thought process. And you can see from step 3, there's a lot of standing dead fuel, the SD component. There's 1,700 pounds per square per acre, which is going to strongly affect fire behavior. And the height in this example is only 1.5 feet, so you're not going to get necessarily, obviously not as high a flame length as you would in like a forested system. And the overall yield of the annual is 1,500 pounds per acre. So we can see, based upon other data sets, based upon what's current, okay, this is in the past, but what's current, what the actual fuel bed is. In this case, it's a GR2. So by looking at these different steps, we can get to what fuel classification we're at. You can go to the next slide, Matthew. So what other resources can you use? We kind of talked about that today. There's lots and lots of data sets out there from different programs, and you kind of, by understanding how these data sets are different and how they can be worked together, you can change your fuel beds, or how you can actually integrate multiple lines of evidence and the resources to make an interpretation. So you can actually kind of come to these conclusions based upon data that you have and your local knowledge. You may also want to indicate other additional indicators of change or changes that may affect fuel, for example, climate, weather, soils. Again, these are all kind of local knowledge things. And then also interpret indicators alongside remotely sensed data in the context of management questions. I also do want to point out that you can actually explore how management has affected fuels, or how management is actually how treatments have affected that, by looking at the land treatment exploration tool put up by USGS EROS from Boise by David Pillier. This is in the bottom left. You can see this example of this tool where it compares, proposed treatments to similar past ones. So whether they've been successful, what's the actual fuel treatment. And so at the end of the day, all these, you can take a lot of these different data sets and make conclusions based on them, which is important. You can go to the next slide, Matthew. So, kind of just to wrap everything up, LANDFIRE is good for fire stuff. It's good for other applications as well, but it was primarily developed for fire applications. Disturbances and potentially more applications in forest. It's heavily originally heavily forest centric. Obviously that's changed through time. We've been improving a lot of layers in the shrub and the herbaceous layers as well, so it's not as much as it used to be, but that was the original focus, especially for forest fires. Whereas the fractional vegetation cover is more tailored to rangeland, which is better for time series. You can see these changes develop, and in answering multiple types of management and disturbance questions. And so with that, I thank you for your time. And I haven't when I've been talking, I haven't really been looking at the meeting chats. I'm not sure if any other questions have come up, but I'm sure I'd like to open up for questions.
Thanks, Josh. There haven't been any other questions in the chat that I've seen anyways. John's helped sort of clarify a couple of things, but I'm sure there are other questions that have arisen since you all have been talking, and we still have about 20 minutes for questions. So now's the time that you're welcome to come off mute or put your questions in the chat window, and Matthew, you can keep sharing or not, whatever you would like.
I'll keep the slides up in case we need to point to something.
Sounds like a plan. No need to raise your hand. Feel free to I can't see, there's too many people on the call, so I can't see if you.
I have a question for you, Matthew. I'll start off. So your data sets are comparable through time. Do you have to go through changes every year to make them backwards compatible? Like I know NLCD does this, for example, or are they just you have the same methodology so that they're comparable every year? You don't have to go change anything through time.
Yeah, so the products are not designed to be backwards compatible across versions. But they are definitely designed to be backwards compatible within a version. So both RAP and RCMAP have now been through several versions of our time series cover predictions, and each new version we retrain a model with new AIM observations, new predictor variables, et cetera, and basically there's a whole new model that's applied all the way back through time to 85. So for that reason, you need to be consistent in an analysis within a version. So backwards compatibility within a version, not across versions.
Cool. Okay, thank you.
I know a lot of these things, the answers to some of these questions are probably a little bit unsatisfactory. It depends. That's I think a lot of the bottom line here is it depends on what you're trying to do. What kind of data you need to answer a certain question is going to drive what data set is most appropriate. And the accuracy of the products vary. I showed the example from the boilerplate accuracy statistics from the metadata. Maybe one product might have higher stats than another. That doesn't necessarily mean that it's always more accurate. It could be that the lesser accurate of the two products is more accurate in certain regions and certain components and whatever. I think the bottom line rule of thumb is look at how these products compare to your local impressions of a study area and other sources of data. Yeah, Tim, you got a question?
Yeah, hey, thanks, Matt. And thank you to all the speakers. I appreciate your time. So I was curious, in my agency, we've talked a little bit about are there opportunities to kind of squeeze a little bit more out of both data sets? And an example might be where we can, take advantage of LANDFIRE's existing vegetation type, for example, a little bit more of their discrimination. And then we can use that maybe let's say we have an oak stand somewhere that we're not, it's tree cover, but we don't know that it's an oak stand if we don't look at LANDFIRE EVT. And then we can identify what that zone is or what that area is. And then we might be able to go to the fractional veg cover products to use them for their strength, which is time series analysis. In my head, that's fairly straightforward, but I'm wondering if you or maybe anyone on the call has done this or could point to a product where that's been, where someone has worked up an analysis that we could maybe use as a blueprint, perhaps.
I'm not aware of any paper that's done that. That's a really good point. Leveraging LANDFIRE in conjunction with these fractional veg products, could add floristic detail to an analysis, like understanding, oh, it's not just trees, it's blue oak or it's whatever. That definitely could be helpful. And on the other hand, I think you could go the other way. You could see, if you're looking at LANDFIRE data, the fractional veg cover products could help understand sort of within state changes within the bounds of a thematic classification in LANDFIRE. Though the classification hasn't changed, that doesn't mean there's no change within that area. You could
Sure.
be leading towards some regime shift in vegetation cover based on invasives or succession or whatever. But to answer your question, Tim, to my awareness, maybe the other co-presenters today can address that as well, but I'm not aware of any paper that specifically looks at that.
No, I can't think of any either. I will say also that, LANDFIRE is kind of more of a dominant cover. And so,
Sure.
It's based on if you nest it from tree to herb, if there's at least 10% tree canopy, it's going to be labeled as a tree. So, I mean, a tree cover. So that's part of the difference to, again, with fractional veg. Even though we do, that's EVC, for example, even though I will say that when we model products, we actually do model every pixel for vegetation cover in each life form. So, but yeah, we don't distribute those.
I wonder if Megan, if you don't mind me piggybacking on here, I wonder if maybe another question is, within this context, and given everybody that's on this call, does anybody see any things to watch out for that might not be obvious in thinking about, leveraging both of these data sets together?
I think I'm gonna if I can jump in while everybody else thinks, and like in the example you provided, Tim, in terms of like an oak dominated, pixel or area, like I think particularly when you're using it to look at tree cover, like neither RCMAP nor RAP have a ton of tree data in their training data sets. Like tree cover's fairly, I would hazard to guess, I don't know about RCMAP, but I'll just speak for RAP. Most of the tree cover values are fairly low because a lot of our data is coming from rangelands. And so a lot of that information is going to be coming from areas where tree cover is less than 30%. So if you're looking at a veg type where it's higher, things to think about.
Yeah, maybe the oak was a poor example in that situation, but I hear you, Sarah. That's certainly one that comes to top of mind. Thank you for that. Yeah, just curious if others have any other, potential pitfalls to watch out for.
And another thing to think about is the definition of a tree. So what is the cutoff for a tree versus a shrub versus herb? And there can be definitional differences between the products. So you should be, aware of those when thinking about this, thinking about them like, well, I think of a juniper as a tree, for example, but this product has it classified as a shrub.
It's funny. That's funny, Joshua. That's never come up before in discussion with AIM and Matt Rigge and others.
No, I'm
just
sure
kidding.
not.
Just kidding, Matt.
Yeah, I know.
Are we going to turn this into a what is a tree office hours?
Yeah, I don't want to do that. I'm just saying.
Yeah. I think another pitfall to be aware of probably is the change detection part of this. Thinking through, LANDFIRE is really only mapping change in their annual disturbance footprint versus a radically different concept of mapping change in the fractional veg cover products. I will say change is another topic that we need to talk about. So the accuracy of these products, all the accuracy stats that have been done to date, in my awareness, are looking at how good a single map is in time. Mapping change is far more difficult. So you got to get the first map right and the second map right, and you're compounding error to get change accuracy right. So that's an important thing to think through, that the accuracy of change will be lower than that is what is reported in the boilerplate stats, at least on average.
So thank you guys so much, Josh and Matt, for your presentation. I really enjoyed it. I am speaking as someone who is not a remote sensor. So, just in layman's terms, I have been cautioned against looking for annual change in remotely sensed products because, as I understand it, there's some noise from year to year. And so, I'm just wondering if you could maybe explain that idea, if that is true, and how you would account for that when using any of the products that you guys described.
Yeah, I'll jump in on that. I think Sarah probably would be great to weigh in on that as well. Um, why would you not look at change from a year-to-year basis? So there are some things to be aware of. Uh, there are phenological anomalies in a given year, uh, like just based on the timing of image acquisition, that could drive some modeling hiccups. There's cloud cover issues, snow cover issues in the imagery itself that could potentially contaminate some of the Landsat composites or otherwise that feed into these models. Uh, so it's sort of analogous to the spatial scale example I provided. The coarser the spatial scale you're investigating, the less error you're going to see in these products. And I think the same is true with temporal scale. So, for example, let's compare 1995 to 2005 and look at the difference in shrub cover between those 2 points in time. That's going to have higher error than looking at the mean of the 5-year window centered on 1995 and 2005 based on just the averaging of a bigger time period. I think it's really analogous to that spatial scale question as well. All of that being said, at least in RCMAP, we provide a lot of post-processing for our time series to clean up a lot of this interannual noise that can happen. A lot of times the model, like it's a very empirical model, so it's just predicting cover values based on a whole database of training values, and you really can't constrain that too much. But I think that's a general good rule of thumb is temporal aggregation can reduce error as well in your analysis. Sarah, I don't know if there's anything you want to add to that.
Yeah, I think where my head goes to this is to look at this from a different angle, which is we have the same problem with field data too. And like it's kind of an ecosystem change detection question that's just broadly applies to any kind of way you're measuring an environment, which is like at what point is the like signal greater than the noise, and how much of that is just due to inherent, based like general stochasticity in our environmental systems, and it's just a slightly wetter year, slightly drier year, some other combination of factors, or is it this like actually a significant like actionable change from a management perspective? And so the more time you have between measurements, the more likely you are to detect a meaningful change, just because you're more likely for that meaningful change to have like manifested in the system, especially in non-disturbance areas like fire. So, where you have one big change from one year to the next, I think you're going to probably fairly reliably detect that using remote sensing. But where those changes are like very small and incremental, that might be hard. That was probably going to be difficult to detect with remote sensing or field data or anything, just because like the signal to noise ratio is going to be fairly low in terms of what we measure. So I guess just some broader perspective, I don't think this is a unique question to remote sensing, and it's more of a like how big of a change are you trying to detect, and what's the tolerance of the data acquisition system you're using.
I fully agree with that, Sarah. I mean, I think the general rule of thumb that we see, we've got a paper looking at sage step data, and how well the remote sensing products RCMAP aligns with the changes observed in the sage step treatments. And the bottom line there is the bigger the disturbance effect, the more likely these things are to be captured successfully with the remote sensing products, which completely underscores what Sarah's saying there. John.
I would just add to that, LANDFIRE works to make the best product the last year that we publish. So we roll all that previous change forward. But if you're not accounting for that change, let's say you get a better processing algorithm between this year and the previous year, you can have substantial classification differences, and overall change is relatively rare on the landscape except for disturbance events. And the difference just in the accuracy between those two products can create enough difference that would put a lot of doubt in your mind if you're comparing two products that weren't explicitly set up to compare change.
Yeah, a quick processing question. I wonder if you guys with RCMAP and RAP have scripts you're willing to share that would help users with basic processing, obtaining data, that sort of thing. Do you have like we have a gentleman developed an R LANDFIRE package that brings in LANDFIRE package into your R environment. Do you guys have some? That's probably a huge question. You probably have a lot of scripts sitting around, but wonder if you have anything that we could look at or share or help you post or do some trials like with Tim's question. Do you have any code that would help?
I'll just speak from the RAP side. I should have had all of my links handy, and I'll try and get them into the chat before we end. But we do have an R package called Wrapper that I'll put in the chat.
With a nice capital R?
It's
yes.
Yeah.
Great.
And then we also have links to Google Earth Engine scripts and all kinds of other resources. So that's all on the Rangelands.app website that I'll post and just put in the chat in just a second. And then anyway, you can find it all there.
Fantastic. Thank you, Sarah.
Yeah, I mean, our data's on Earth Engine, Climate Engine, all those as well.